Imagine a world where instead of testing drugs on animals or relying solely on traditional cell cultures, we can stimulate the behavior of human organs on a microchip. That's the promise of organs on a chip. They're basically miniature models that mimic the structure and function of organs within the human body. Hello, 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 and welcome back to, well, I guess this isn't the climate crisis anymore. But today we're going to be calling this the Biotech Breakthroughs podcast. So I'm going to be switching over more to biomedical engineering in the new world and the different innovations that they're making. But if anything comes up that's interesting, I will still always be back on the environmental related topics. So on today's episode, we're going to dive into a groundbreaking innovation that's reshaping the future of medicine, and that's organs on a chip. We're going to be exploring this incredible technology that's basically changing the landscape of biomedical research and drug development. But you may be wondering how these chips work. So basically, there's little micro devices that contain living human cells arranged in a way that replicates the complexity and functionality of actual organs. For example, a lung on a chip would have cells arranged to stimulate like the air sacs and blood vessels that would allow researchers to observe how diseases like asthma or infections can impact lung function. The goal of organs on a chip aren't to replace organs, but to create models that mimic specific aspects of their function. And these models can provide a platform for testing drugs, understanding disease mechanisms, and potentially reducing the need for animal testing in pharmaceutical research. One of the most incredible aspects of organs on a chip is their ability to provide real time data. They allow scientists to observe how organs would react to different drugs or environmental factors without the need for invasive procedures or, like I said before, animal testing. And this basically will accelerate the drug development process because you don't need to rely on living organisms for testing. And it just makes this whole process more ethical. So now we'll go on to the impact of organs on a chip. Organs on a chip hold tremendous potential to revolutionize personalized medicine. So imagine a scenario where a doctor can test a patient's response to a specific drug using their replicated organ models before actual treatment, which optimizes therapies for individual patients. So instead of having a one size fits all treatment plan, these organs on a chip would have specific cells that are the actual cells of the real patient. And these chips would be able to create real time data, which shows how the actual patient would react to drugs used on their body. So instead of harming the patient, potentially harming the patient by one size fits all drugs, this would create therapies for individual patients and optimize their efficiency. Moreover, these chips open doors for studying rare diseases that were once challenging to replicate in traditional models. Researchers can create personalized chips using a patient's own cells, providing insights into how their unique body responds to treatments. However, as with any groundbreaking technology, there are challenges. While organs on a chip mimic the microenvironment of organs, they may not fully replicate the complexity of the entire body. So there's still ongoing research to enhance the accuracy and mimic more organs with higher accuracy. Nonetheless, the potential of organs on a chip is immense. They've already been used to study diseases like Alzheimer's, cancer, and even test the toxicity of new drugs more accurately. They're paving the way for safer, more effective, and personalized treatments. Before we wrap up, we should think about the future possibilities of organs on a chip. Imagine a library of personalized organ chips, which will aid doctors in predicting individual responses to treatments, reducing adverse reactions, and potentially saving countless of lives. That's a wrap for today's exploration into the fascinating world of organs on a chip. Thank you for tuning in. Remember, this technology represents the convergence of biology, engineering, and medicine, offering hope for a healthier tomorrow. Thank you for watching or listening to Biotech Breakthroughs. Until next time, stay curious and keep on exploring the possibilities of the intersection between science and technology. Leave a comment below on what was your favorite part of the video and a comment below on what you want me to talk about next. Bye bye!